Hello everybody, welcome into another lesson. So today we are going to talk about defining recursive formulas for arithmetic and geometric sequences. So up till now we've been dealing with what's called an explicit formula for these. So for an arithmetic sequence, the explicit formula of course is a sub n equals your a sub 1 plus the quantity of n minus 1 times d. So explicitly for an arithmetic sequence, this always relates the very first term of the sequence to what position you're seeking in the sequence times your common difference. And then with the geometric sequence, the explicit formula is a sub n equals a sub 1 times the common ratio to the n minus 1 power, which again relates your first term to that common ratio with what position of the sequence you're seeking. Those are explicit formulas. Now, recursive tends to make things a little bit easier, believe it or not. If you're looking to find the immediate next term of a sequence after a term, so a sub n will equal a sub n minus 1 plus your common difference. So for example, if I want to find the third term of a arithmetic sequence, I just take the second term and add the common difference to it, and I have the third term. So my first term at this point could actually be irrelevant. As long as I know a term, I can find the next term and add the common difference. I can find the next term by adding the previous and the common difference together. For a geometric sequence, the recursive formula is a sub n equals the common ratio times the previous term. So if I know one term, if I know a term, I can take that term, multiply it by the common ratio, get the next term. So again, the first term is irrelevant in recursive situations. I can find the next term by doing that. So let's get into some examples here. I'm always dropping stuff, I tell you. Alright. Now, this case, we're going to have a geometric series sequence where the first term is 2 and the common ratio is 10. So we have the first term is 2, the common ratio is 10. We're going to find both an explicit and a recursive formula. So for the explicit, we always take for a sub n, that's going to equal your first term, in this case, which is 2, times your common ratio of 10 to the n minus 1 power. So there's your explicit formula. Now what about for a recursive? If we were to find a recursive formula for this, your a sub n would equal your common ratio of 10 times the previous term, which would be a sub n minus 1. That's the recursive formula. Now, we're also going to find the first 5 terms of the sequence. So let's say we want to find a sub 2. Well, that's just going to equal 10 times a sub 1, right? Which would equal 10 times 2, which would equal 20. So my a sub 2 is 20. Let's find a sub 3. So that's going to equal 10 times my a sub 3 minus 1, which would be 10 times a sub 2. So that would be 10 times 20, which should end up giving me 200. If I want to find the fourth term, that's going to be 10 times my a sub 3, which would be 10 times 200, which would give me 2,000. Then if I want to find the fifth term, I would just take 10 times my a sub 4. So that's going to be 10 times 2,000, which would give me 20,000. So the first 5 terms of the sequence are going to be 2, 20, 200, 2,000, and then we'll put a semicolon there, and then 20,000. In fact, why don't we put semicolons everywhere so we have the list of terms? So using a recursive formula is sometimes easier than trying to plug it into the explicit formula, trying to figure out exponents and multiplication. You just take your common ratio times your previous term and you can get the next term in the sequence. Alright, so let's see here. Let's do another example. You are given the first term equals 3. This time you're given the common difference is 10. So you have the first term and you have a common difference, which means this is an arithmetic sequence. So let's first find the explicit formula. The explicit formula, of course, is going to be a sub n equals your a sub 1, which is 3, plus the quantity of n minus 1 times your common difference of 10, which would equal 3 plus 10n minus 10, which means the explicit formula ends up being 10n minus 7. So that's the explicit formula for this arithmetic sequence. Now let's find a recursive. A recursive formula for this would be, if you want to find the next term, you just take the previous term, your a sub n minus 1, and add 10 to it. That's all you got to do. Take your previous term and add 10 to it, and you have your next term. Now let's find the second, third, fourth, and fifth terms. So the second term would equal a sub 2 minus 1, which is a sub 1, so that'd be 3 plus 10. So your second term is going to be 13. Let's find your third term. Well, that would be a sub 3 minus 1, which is a sub 2, so that would be 13 plus 10, meaning the third term is 23. Find the fourth term. That's going to be a sub 4 minus 1, which is a sub 3, so that's 23 plus 10. That would equal 33. Then we'll find the fifth term. That's going to equal a sub 5 minus 1, which is a sub 4, so that's 33. Then add that common difference of 10, you get 43. So the first 5 terms of the sequence are going to be 3, 13, 23, 33, and 43. That would be the first 5 terms of the sequence: 3, 13, 23, 33, and 43. So personally, I like using recursive formulas more. It's a lot less strenuous. Alright, now we have the first term of this series equals 10, and you're given a common ratio of 2. So you have a common ratio, meaning this is a geometric sequence. So let's find the explicit formula for this geometric sequence first. That, of course, a sub n would equal your a sub 1, which is 10, times your common ratio, which is 2 to the n minus 1. So there's your explicit formula for the sequence. Now let's find the recursive formula. The recursive is just simply going to be a sub n equals that common ratio of 2 times your a sub n minus 1. So it's just 2 times the previous term. I think this is going to be a lot better to work with. Now let's list out the first 5 terms of the sequence. So a sub 2 would equal 2 times a sub 2 minus 1, which is 2 times a sub 1. So that'd be 2 times 10. Well, that's going to give you 20. Now let's find a sub 3. that would equal 2 times a sub 3 minus 1, which is a sub 2, so 2 times 20. That means your third term is going to be 40. Let's find a sub 4. So that would equal 2 times your a sub 4 minus 1, which is a sub 3, so 2 times 40. That's going to make your fourth term 80. And then let's find the fifth term. That would be 2 times a sub 5 minus 1, which is 2 times a sub 4, so 2 times 80, that would be 160. So the first 5 terms of the sequence are 10, 20, 40, 80, and 160. Those would be the first 5 terms of your sequence. And if you wanted to, you could test these in your explicit formula, but you're really doing more work than you need to. Just use your recursive. You'll do less work that way. And some of you are probably wondering, why didn't you teach us the recursive formulas first? Well, it's important to know where all this comes from. That's why the explicit is taught first. Alright, now we have a sub 1 equals 5. This time you have a common difference of 3. So you have a common difference. This is an arithmetic sequence. So let's find the explicit formula first. So let us find the explicit first. That's always a sub n equals your a sub 1 in this case, which is 5, plus the quantity of n minus 1 times your d of 3. So that would give you 5 plus 3n minus 3, meaning your a sub n would equal 3n plus 2. There's your explicit formula for this particular arithmetic sequence. Now let's find the recursive formula. The recursive is much simpler to work with. To find your next term, you'll take your previous term, a sub n minus 1, and just add that common difference of 3. So a sub n equals a sub n minus 1 plus 3. Now let's find the first 5 terms of the sequence. We already know the first term, so a sub 2 will equal a sub 2 minus 1, which is a sub 1, so that'd be 5 plus 3, which gives you 8. Then a sub 3, that would equal a sub 2 plus 3, so that would equal 8 plus 3, which equals 11. A sub 4 would equal a sub 3 plus 3, so 11 plus 3 would equal 14. Then a sub 5, that would equal your a sub 4, which is 14 plus 3, which would give you 17. So the first 5 terms of the sequence are going to be 5, 8, 11, 14, and 17. Those would be the first 5 terms of the sequence. I have 5 more. All right. A sub 1 equals 0. Your common difference is negative 1. So you have a common difference, so that means this is an arithmetic sequence. So let's find the explicit formula first. So that's where a sub n equals your a sub 1, which in this case is 0, plus the quantity of n minus 1 times your difference of negative 1. Well, 0 plus anything is that anything. This would end up equaling 1 minus n. So a sub n equals 1 minus n. Okay, that's not so bad. But let's find the recursive. The recursive, of course, will be a sub n equals a sub n minus 1, meaning your previous term plus that common difference of negative 1, which in this case would be minus 1. So a sub n would equal a sub n minus 1, all that minus 1. Now let's find the first 5 terms of the sequence. So we already know the first one, 0. The second term, a sub 2, would equal a sub 1, which is 0 minus 1, which would give you negative 1. Let's find a sub 3. That'll equal a sub 2, which is negative 1 minus 1, which would give you negative 2. A sub 4 would equal a sub 3, which is negative 2, then minus 1 would give you negative 3. Then a sub 5 would equal a sub 4, which is negative 3 minus 1, which would give you negative 4. So the first 5 terms of the sequence are going to be 0, negative 1, negative 2, negative 3, and negative 4. Those are the first 5 terms of this particular sequence. All right, 4 more. A sub 1 equals 5. Your common ratio equals 2.5. All right, so we have a common ratio. In other words, this is a geometric sequence. So let's find the explicit formula first. The explicit formula, of course, for a geometric sequence is a sub n equals your a sub 1, in this case, which is 5, times your common ratio r, which is 2.5, to the n minus 1 power. So a sub n would equal 5 times the quantity of 2.5 to the n minus 1 power. Okay. Well, now let's find the recursive formula. The recursive, of course, is going to be a sub n. Your next term would equal your common ratio of 2.5 times your previous term, which is a sub n minus 1. Now let's go ahead and find the first 5 terms of the sequence. We know the first one. How about the second one? A sub 2 would equal 2.5 times your first term, which is 5. So what is 2.5 times 5? I think that's 12.5. I was right, it's 12.5. So your second term is going to be 12.5. Now let's find the third term. That's again going to equal your common ratio of 2.5, this time times your second term, which is 12.5. Let's see what we get here. That would equal 31.25. All right, let's find the fourth term, which would equal that common ratio of 2.5 times your third term of 31.25. Let's see what we get for that bad boy. So we get 78.125, and let's find the fifth term. A sub 5 would equal 2.5 times that a sub 4, which is 78.125. Let's see what we get for our fifth term. So we get 195 point, I believe, yes, 3125. So the first 5 terms of the sequence are going to be 5, 12.5, 31.25, 78.125, and 195.3125. Those would be the first 5 terms of the sequence. All right, I should have just 3 more. All right. A sub 1 equals 14. The common difference is 1/2. All right, so the first term's 14, then you have a common difference of 1/2. So this is an arithmetic sequence. So let's find the explicit formula first. So a sub n would equal your first term, 14, plus the quantity of n minus 1 times your common difference of 1/2. So that's going to equal 14 plus 1/2 n minus 1/2, which means the explicit formula is a sub n equals 1/2 n plus 27 halves. So there's your explicit formula. A sub n equals 1/2 n plus 27 halves. All right, let's find the recursive. So since we have a common difference, that means your next term, a sub n, would equal your previous term, a sub n minus 1, plus that common difference of 1/2. So let's find the first 5 terms of the sequence. We already got a sub 1, so a sub 2 would literally equal your a sub 1, which is 14 plus 1/2, giving you 14.5. How about a sub 3? Well, that's going to equal your second term of 14.5 plus another half, which would give you 15. A sub 4 would equal your a sub 3, which is 15 plus half, which would end up giving you 15.5. And then to find a sub 5, you'll take a sub 4, which is 15.5, and add yet another half, and you should get 16. So the first 5 terms of the sequence are going to be 14, 14.5, 15, 15.5, and 16. Those would be the first 5 terms of the sequence. And I got 2 more. All right. A sub 1 equals 1/2. You're going to have a common ratio of 4. So a sub 1 equals 1/2. Your common ratio is 4, which means this is a geometric sequence. So for the explicit formula of this geometric sequence, let's find that. Well, that is always going to be a sub n equals your a sub 1, which in this case is 1/2, times your common ratio of r, which in this case is 4 to the n minus 1. So there's your explicit formula for this sequence. Let's find a recursive. So a recursive is simply going to be to find the next term, a sub n. That's going to equal your common ratio of 4 times your previous term, a sub n minus 1. A lot easier to work with, right? Now let's find the first 5 terms of the sequence. We know the first term is 1/2, so the second term would equal 4 times 1/2, which would be 2. Find the third term, that's going to equal 4 times your second term of 2, which would give you 8. Find your fourth term, that would be 4 times your third term of 8, which would be 32. And then find your fifth term, that would be 4 times your fourth term of 32, which would end up being 128. So the first 5 terms of the sequence are 1/2, 2, 8, 32, and 128. Those are the first 5 terms of this particular sequence. And I got just one more. a sub 1 equals negative 1, you have a common difference of negative 3/2. Alright, so you have a common difference, meaning this is an arithmetic sequence. So let's find, of course, the explicit formula first. That's going to be, of course, a sub n equals your first term, a sub 1, which is negative 1, plus the quantity of n minus 1 times your common difference of negative 3/2. So this would become negative 1 minus 3/2 n plus 3/2, which means that a sub n is going to then equal 1/2 minus 3/2 n. So a sub n equals 1/2 minus 3/2 n is your explicit formula for this arithmetic sequence. Now let's find the recursive, which will be much easier to work with. The recursive is just going to be a sub n equals your previous term, a sub n minus 1, plus that common difference of negative 3/2, which in this case would be a sub n minus 1 minus 3/2. Now let's find the first 5 terms of the sequence. We know the first term, so let's find the second term. That would equal the first term of negative 1 minus 3/2, which would give you your second term, which would end up being negative 5/2. Now let's take and find your third term. So that's going to be your second term of negative 5/2 minus negative 3 minus 3/2. That would give you negative 8/2, which is simply negative 4. Let's find the fourth term. So that's going to be your third term of negative 4 minus 3/2, which would give you negative 11/2. And then to find a sub 5, you'll take your fourth term of negative 11/2 minus 3/2, which would give you negative 7. So the first 5 terms of the sequence are negative 1, negative 5/2, negative 4, negative 11/2, and negative 7. Those would be the first 5 terms of your sequence. So that's it for the sequence and series unit. The next lesson, we're going to start a small 3-lesson unit on counting principles. That includes factorials, permutations, combinations, and the binomial theorem. We'll get into all that. So I hope everyone has a great day. Take care.